Yeah, good afternoon. Good afternoon.
Good afternoon, sir.
Happy Sri Ram Navami. Hmm? Rama bless you all, pa. Okay.
Yes, thank you.
Happy. He will give happiness and health to you and all of us, right?
Yes, sir.
Now we'll start. There are only 4 participants are there. We'll wait for another 2 minutes, and later on we'll start. Okay. Benita, you put some message,
Yes, sir.
Benita. Uh, let them join quick.
Yes, sir.
Okay.
Yes, sir.
Yeah, we'll start with yesterday's program. I'll start sharing the program. We'll rediscuss the program. Once again, I will trace line by line code, and we will see how that particular program is going to be works. Okay. Okay. Hello.
Yes, sir.
Yeah. I'll share
Yes, sir.
I'll share the screen. So yeah, this is a Word file which I want to share. Yeah. Now, one minute. Recording is going on, I think, right? Yeah. Back here. Now, this is a program which we have told you yesterday. Observe carefully. Now, here we are going to use 2 arrays and C1, C2, C3 and I. So what for 2 arrays we are going to use? First array is meant for an sender side data, means sender will take first data and it will add up the check bits into that. And in a last class for a humming code, I have told you very clearly that the check bits whatever will be there will be placed at 2 to the power of 0 place. Sorry, 2 to the power place. That is 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. In that particular positions, the check bits will be placed. Here coming to the 7 bits code. In a 7 bits code, 4 data bits will be there and 3 check bits will be there. Why? Because if I consider 1 to 7, there 1 stands for 2 to the power of 0, 2 stands for 2 to the power of 1 and 4 stands for 2 to the power of 2. none other numbers is a power of 2. Because of that, with 3 check bits and 4 data bits, a 7 code will be there. Now, if taking a 7 code example, we'll start with our program. Yesterday, I shown you how in a circles, if we have written 3 circles intersecting with each other, the circle names will be, first circle will be 1, second circle will be 2, and the third circle will be 4. And the one circle, whatever is there, which is intersecting with the second circle, at that intersection, 1 and 1 plus 2, 3 will be there. And then the 1 and a fourth circle where intersecting, 5 will be there. 4 and 2 intersection, it will be 6 will be there. And then intersection of 3 circles, that is 4 plus 2 plus 1, that is 7 will be there. The 3, 5 and 3, 5, 7 will represent whatever the thing, 6 will represent the data bits. This 4 will represent the data bits. First we'll write a data bits there, and later on we'll take 1 by 1 circle and we will check. That is, either the even number of ones is there. If even number of ones is there, for a check bit, we are going to assign 0. We are going to assign 0. After assigning a 0, based on the even number of ones in that circle. One circle first we'll see. Yesterday I taken a PDF format of that entire notes and I have sent you. There I have written very clearly at each every circle. So how many, because of how many ones, even ones, either it is 0 or a 1. If it odd ones are there, it will become 1. Either it's a even ones are there, it will become 0. Now coming to the program, yesterday I have sent a program also to you. Now I will explain a line by line of a program here. First, we will take data as an array of 10, which we have declared. Now observe the instruction here. Printf, enter 4 bits of data one by one. We are asking a user to enter 4 bits of data one by one. That is data 0, data 1, data 2 and data 4 positions. We are going to insert the user data. Now observe here, I think you can see here, right? Now observe here, I have taken data very clearly. You can see here, you can see here. So I have taken a data very clearly. That is how the things it will be there. That is the positions I have taken. Now coming to the things, assume that we are taken the input as 1 0 1 0 1 0 1 0. Everyone keep notes with you, pen with you. Assume that we have taken an input of 1 0 1 0. Now the first one will goes to data 0 position, that is 1. Data 1 will become 0. Data 2 will become 1. Data 4 will become 0. Are you getting? I repeat, are you getting? Are you getting? Hello?
Yes, sir.
Hello? Yeah. I repeat once again. See here we are taking an input for data array. In a data array we are taking only for position 0, 1, 2, 4. Now if I give an input 1 0 1 0, assume 10. In a binary format I am giving 1 0 1 0. Now data 0 of an array will get 1, data 1 of an array will get 0, data 2 of an array will get 1, again data 4 of an array will get 0. Now what is our next intention? We have to calculate for the values for positions data 3, data 5 and data 6. Now coming to the next step, the calculation of a even parity, which you are going to see here. So this is the even parity calculations. Then how here the calculations will be done. Now observe the data 6 calculation, how we are doing. As I told you in a last class that the power symbol, what we are going to use here is stands for a bitwise XOR operation. Bitwise XOR operation. What is a XOR operation? XOR operation is if the input bits are same, the output will be 0. If input bits are different, the output will be 1. That is 0 and 0 is 0, 1 and 1 is 0, 1 0 is 1, 0 1 is 1. Now coming to this formula here. Now observe that the value of data 0, everyone, the value of data 0 according to our example is 1. 1, now observe here. Now observe here, this side, I think you can observe clearly. I'll stop sharing just for a sake now. I will see the example, then you can understand easily. Just I'm stopping the sharing. Now you can see here the things clearly. Yeah. Now you observe here, the left side, whatever is there, this is a data bits I have taken. Data 0 is 1, data 1 is 0, data 2 is 1, data 4 is 0. Now observe the calculation here, what I am going to do for a data 6. Data 6 is here below, data 6. So as according to the formula there, the data 6, I have taken a values from this data inputs. Now observe here 1, the bitwise operator power symbol 0 and power of 1. So that if you take into the consideration, the last 2 bits from right side, the calculation will be done. The last 2 bits you are going to take into the consideration. That is 0 power symbol 1. 0 power symbol 1 means in XOR. 0, 1 means it is 1. Why? Because the input bits are different means the value will be 1. So 1. Now next coming out is 1 is there and here 1 is there. So 1 XOR of 1, the bits are same. 1 XOR of 1 is 0. Like that, we are going to do a calculation here. That is, data 3 will stands again for 0. Why? Because 1 power symbol, observe here, 1 power symbol 0 and again power symbol 1 is there. 0 right side. 0 power of 1 is 1. 1 power of 1 is both are 1 1. So 0. Now observe here, data 5 will change. How data 5 will change? 0 power of 0 is 0. Why? Because 2 are same. 0. But here 1 is there. 1 power of 0 is 1. Why? Because 1 and 0 is 1. Like that, we are going to get for another 3 positions also. Finally, we are displaying here. Finally, we are displaying according to the program. We are displaying this encoded data. The encoded data is according to the positions 1010 will become 1010010. 1010 input will become with check bits, that is 1010010. Now coming back to the program, again I'll share. Coming back to the program, yeah, coming back to the program, now I told this calculation step. In this calculation step, once again I'll tell you very clearly, whatever the above data you are taken, just that values you input here. That is, the first calculation will be done with these 2 things. That is, for example, data 2, what value you given? Power of data 4. That is, this XOR of this. Whatever output will come, that will be taken with the next remaining input. Like this you are going to do. Finally, the encoded data, whatever is there here, the printf encoded data, that is the 7 bits data from 0 to 6 will be printed here. That I have shown you. Now, okay, this is the sender part. After encoded, it will be sent to the receiver. Now, what the second array we are going to use? Data at receiver side. Again, we are asking a user, you enter data at receiver side. If user enters the same encoded data, observe carefully, if user enters the same encoded data, this encoded data and this data received, if he enters the same, then what happens? Then observe here, this is a one case I am telling. Assume that the same thing here the user also entered. That is, the user also entered 101010. Now, first you assign the positions to that particular received data. Means you write that 7 bits, whatever is there, and you assign a positions to that, that has 0, 1, 2, 3, 4, 5, 6 until 6. From left to right only you have to assign. After assigning, you will get a positions. Now you have to do the calculation for C1, C2 and C3. Now observe carefully how you have to do this calculation. First, these two things will be evaluated, right? Afterwards, these two things will be evaluated, right? And next, the output of this will be evaluated later on with this particular symbol. In this way, the bitwise operator execution will be done. I repeat once again. See, first the right side, two operands will be taken. The XOR will be evaluated for these two. Then the output will be taken. Then these two, whatever left side is operands is there, these two will be evaluated. The output will be taken. This output plus XOR of this output will be the result of a C1. Now again we'll go back to the sharing. Now you see how the calculation we are going to take into the consideration. Now I will stop this sharing. Now back here. Now you see again very clearly I have written here the positions. See here. If user enters the received data as encoded data, same data, if he enters there, now you see here, now 1010010 is there. I've given a positions here 0, 1, 2, 3, 4, 5, 6. According to that, I have calculated C1, C2, C3. How I have calculated C1, C2, C3? Now I have taken like this 0, power of 0, power of 1, power of 1. These two I have did the first. That is 1 and 1 is 0 and left side 0 and 0 is 0. Are you getting? Finally 0 and 0 is 0. Now 1 and 0 is 1, 0 and 1 is 1, 1 and 1 is 0. Then 0 and 1 is 1, 0 and 1 is 1, 1 and 1 is 0. Now C1, C2, C3 all are 0. Once C1, C2, C3 are calculated, now below one formula is there. Again I will go to the sharing. Now you see this. Again formula is there. Just a minute. Yeah. Now you see the formula. This formula will decide whether the data what you have sent is correct or wrong. Now we are calculating C, that is C3 into 4 plus C2 into 2 plus C1 will become C. Here C3 is 0 according to our example, C2 is 0 and C1 is 0. That is 0 into 4 is 0. 0 into 2 is 0, C1 is 0. That is 0 plus 0 plus 0. 0 plus 0 plus 0 is 0. Now you come to the next part of your program. Here we are going to decide. If C is equal to 0, no error while transmission of data. Observe carefully. No error while transmission of data. Now, printf error on position so and so. What is this so and so? The C will tell at that particular position the error is there. Printf data sent. Whatever data sent, we are going to take from data, and whatever data received will be there here. Now how to correct that particular data? Humming code will do the correction also. That you have to keep in your mind. So how the correction will be done? Now come back here with our example. Assume that if the encoded data, whatever is displayed, and again you will ask the user, enter user received data. In a received data, while entering, if you do a mistake while entering in a received data, assume any one bit will give wrong in that particular thing, identifying a position. So now the C will give you that particular position and it will tell at that position the error is there. And both the data at receiver side, this array will indicate, I am highlighting, this array will indicate sender data, means whatever sender encoded data, and this is received data, data at receiver, what user has entered. So if both are same, no problem. If error is there, so it will displace, then the correction has to be done. How a correction will be done here, observe carefully. If data received 7 minus C is equal to 0, observe carefully. The whatever a position is there here, assume there is a error in a second bit. If second bit error is there, that is 7 minus 2, that is data received of a fifth bit. If it is equal to 0, then what happens, the fifth bit will be converted to 1. Else observe carefully, else what happens, now data received 7 minus C will become 0 only. Now in this way the correction will be done. How a correction will be done, whatever a position is given, I repeat once again, if errorness bit is 0, we implement it, else vice versa. If data received, means whatever user has entered received data, their error is there at 2, assume 2 error is there, means 7 minus, from our left side it is 2, means 7 minus 2 means 5. From right side it will become a fifth bit. If that particular bit is equal to 0, we'll make 1. Otherwise we'll make 0. Means vice versa will make. Either 0 is there, it will become 1, or 1 is there, it will become 0. In this way the correction is going to be done. This C indicates exact position of that particular thing. In our array cases, always we'll go read from left to right. Assume, why, you may ask me question, sir, why this part is needed? This is your doubt. Everyone will get this particular doubt. Am I right? But computer reads always data from right to left. This you have to keep in your mind. But in our program, we are reading from left to right. So assume that the position is there at second position. C is equal to 2 means we'll think that second position. No, it's not actually the second position. If you read from right to left, it is the fifth position. At 7 minus 2, that is a fifth position, error is there. Like that, you have to take that into the consideration. I repeat once again, you can get in a computer program, if you deal with arrays, we'll treat from left to right, but actually always the codes will be read from right to left. Now if I get a C bit, for example, enter received data, purposefully I will give second bit error. According to me, from left side I will read, I will give the second bit error. 1 is there, I will make it as a 0. Now observe carefully here, 7 minus C is equal to, assume for example the 7th bit, whatever is there, I will give a error. For example, I will tell you, 7th bit I will give a error. According to me, from left to right, 7th bit, assuming my things here, right? So assume my fingers here, right? We'll read from left to right. Now 7th bit, according to me, 7th bit left to right means this is the 7th bit. See, I will bend this. This is the 7th bit. 7th bit error is there, assume C value. Now 7 minus 7 is 0. Now if you read from right to left, this finger is 0th bit. Correct? No? So if it is 0, I will make 1. If it is 1, I will make 0. This is the procedure. And after making correction, we are going to display the corrected received message another time. So in this way, this is a very simple program. In this way, the humming code program will be executed. Any doubts is there, you can ask me. It's open for discussion. Any doubts is there? Whatever example I have solved you, I will send that in a PDF format. Keep the program one side. Take the example in another side. What I have solved, you solve with another example. You take, I have taken 1010. You take, for example, 1101. Okay, you take 1101 as an example. You sit and you solve according to what I have solve like that. If you solve, you can understand the program very clearly. After understanding a program, you run that particular program in a VMware. If you in a VMware also you can run, or in C means Turbo C also you can run this program, not a problem. So you can run this particular program. While giving the bits, be careful. Bits are individual bits here. That is, if I give 1010, I can't give 1010 in one shot. One space zero like that, or one enter zero like that. One single input you have to give. In this way, the humming code program you have to execute. Any doubts is there, you can ask me. Now it's open for discussion. Please enable your audio. Now it is open for discussion. Hello? 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 Enable your audios. Enable your audios. Listening?
Yes, sir.
Maithili. Hello.
Yes, sir.
Understood. Any doubts are
Sir.
there? Any doubts?
No, sir.
See, you first, whatever the now PDF format of solving problem I will send you, take that, take a program, take another input of 1101, you solve. Everyone you have to do like this. If you do exercise like that, then you will understand this program very clearly in exam. It will help you very clearly. Okay? Okay?
Yes, sir.
Yeah. Now
Okay,
I will
sir.
back. Now I will back to our normal syllabus lesson. Now I'll stop sharing. You can see that. Yes, I'm stop sharing. Now we'll come back to the lesson. Now once the error detection and error corrections of the methods we have did according to our syllabus in a second module. So first, in error detection methods, we have discussed the parity bit checking. In that, the two-dimensional even parity bit check we have taken, and I have sent you a problems also. Then we have gone with the another one method, that is CRC, the cyclic redundancy check. Whatever is there, we have taken that, and I have explained you the algorithm. And we have taken how the GA of X will considered, and how the data, how we are going to take a redundant bits, and how the division will be done using modulo 2. And receiver side, how it will be taken into the consideration. In this way, we have solved CRC. And coming to the next error correction method, that is humming code, which is not there in your syllabus, but lab program is there. Due to that particular reason, the humming code also I have taught you that. So how the humming code correction methods means, first it will detect where error is there. Afterwards, whatever bit is there, it will convert opposite to that. That's it. It's a simple work of humming code. First, it will detect whether it is 1 or 0. Means which position error is there. Then automatically at that position, if 1 is there, it will make 0, or 0 is there, it will make 1. So in this way, the humming code will also work. Now, after doing all these things, we'll go to the next step. Assume once this operation will be done, means error detection and correction will be done by receiver side. Once the other system which is connected or a host system which will do this particular thing in a data link layer, that assume that there is an error in a frame. It has to intimate the sender that this particular frame is error, and retransmission of that particular frame should be done by the sender again. Then how this process will be done? We will call this as a reliable transmission. Very important this is. Why? Because assume there is an error in a frame means keeping that frame, it can't keep a false information, or false information cannot be forwarded to the other systems. So the whatever the host system is there, it should intimate back the sender that this particular frame is errored frame. So how this process will be done? So that we are going to discuss in coming topic, that is the reliable transmission. So how reliable transmission will be done? Now coming to the, I will share this, just 1 minute. Just 1 minute, 1 minute. Huh? Be online, just 1 minute. I'll close this. Yeah. So whatever this is the and already time up. One just. Yeah, I'll share again. Yeah, now here back. Now I'll share this. Yeah, now you see this reliable transmission. CRC is used to detect the errors. Usually, humming code we don't take for the particular error corrections. Why? Because if single bit error, humming code can do. If double bit errors are there, a parity bit also will file there in detecting, and here humming code will also file. If single bit correction is there, humming code can do. The question if you ask me, sir, in that 7 code, if 2 bits error are there, humming code can solve. I can tell no, humming code cannot solve that particular thing. That's why actually in a real world example, we are going to use CRC. CRC, what it will do, whatever may be the big M number of bits are there, for that, based on a generator, we'll add up a redundancy and we will solve. That's why CRC is very much important, and it is a very important question for exam also. Now coming to after CRC detection, if errors is there, some error codes are strong enough to correct errors. To overhead is typically too high. Corrupt frames must be discarded. Whatever corrupted frames are there, it should be discarded and it should ask. Observe the next point here. A link level protocol that wants to deliver frames reliably must recover from this discarded frames. This accomplished using a combination of two fundamental mechanisms. Observe, these two mechanisms will play an entire role, that is acknowledgements and timeouts. What is this acknowledgements and timeouts? As a user, as a sender, what I will do, I will send a frame and I will wait for some time. Within a time, if I get acknowledgement from a receiver that okay, your frame is correct, that means the entire part of that frame will be sent back to the sender by the receiver. That means frame reached correctly without errors. For example, if receiver received the corrupted frame, it will discard that frame. It doesn't send you the send the acknowledgement to the sender. Now, here sender side, you will wait for some time, I told. That is timeout concept. You will wait for some time. After timeout, automatically the retransmission of that same frame will be done by the sender. Then the receiver will receive that frame. Again, error detections will be done. Yes, if now it is correct, again that error part will be sent back within a time. Then the sender what? Yes, now frame received correctly, the new frame will be sent again. Now, this concept, the acknowledgements and the timeout concepts, is a reliable transmission concept. Taking that into the consideration, from next class, we'll go in depth and we'll see how this different types of reliable transmissions will work. That is the stop and wait method or the sliding window protocols, how all this bitwise sliding window protocol, how all these different methods will work, and what are the disadvantages and advantages of the sliding window protocol, and how the sliding window protocol windows will work, we'll discuss in a next class. According to the timetable, the next class will be there on Saturday, that is I think that is on a 4th hour. 4th hour means 11:50 to 12:50. So my class will be there, and the next class will be there on Saturday, 11:50 to 12:50. Everyone join an online. Now you do humming code program. You are having 1 day free. Execute that. Any errors you are getting, please ask me. Be free to ask the doubts. Okay. Now I'll stop this sharing. Stop sharing. I'm leaving the meeting now. Thank you very much for all the participants. Hello.
Thank you, sir.
Thank you, sir.
Thank you very much. Thank you.
Thank you, sir.